Imagine holding something that looks calm and solid, yet was born from intense heat, toxic fumes, and precise chemistry. Most people never think about this, but epoxy resin begins its life as one of the most reactive substances inside a factory. You can't see the danger at first glance, and that's what makes it so surprising. In the next few minutes, you're going inside a world where a tiny mistake can ruin thousands of tons of material. And what happens next even shocked experienced engineers. You might think epoxy resin is just plastic, but here's what nobody tells you. This material can bond steel to steel, survive deep sea pressure, and handle extreme heat without breaking down. Think about this for a second. Entire airplanes, wind turbines, and skyscrapers rely on it every single day. The journey starts far away from the factory floor, in places most people will never see. And this is where the story truly begins. The first key ingredient comes from crude oil, pulled from fields in Saudi Arabia, the United States, and offshore platforms in the North Sea. That oil travels thousands of kilometers by pipeline and tanker before it's cracked into smaller molecules. Inside refineries, extreme heat breaks it down into chemicals like propylene and benzene. These are refined to over 99.9% purity, because even tiny impurities can destroy epoxy later. But this is only half the equation. The second critical material is chlorine, and this is where things get dangerous. Chlorine gas comes from massive salt mines in China, India, and Australia, where salt is dissolved and split using electrolysis. The process runs at around 90 degrees Celsius and consumes an enormous amount of electricity. One factory can use as much power as a small city. And if chlorine leaks, the consequences are immediate and deadly. These raw materials don't travel alone. They move in sealed steel rail cars, special tanker trucks, and pressurized containers designed to survive crashes and earthquakes. Every shipment is tracked in real time, because delays can cost millions of dollars per day. Environmental teams monitor emission spills and waste around the clock. But even with all these safeguards, something unexpected always waits ahead. And this is where the chemistry truly comes alive. Inside the factory, everything starts with a reaction vessel taller than a 5-story building. Epichlorohydrin and bisphenol A flow in at carefully measured rates, down to fractions of a gram per second. The temperature rises to around 120 degrees Celsius, or 248 Fahrenheit, and pressure climbs to nearly 4 bar. You can hear the low rumble as massive agitators spin at 60 revolutions per minute. This is the exact moment epoxy resin is born. The chemical reaction releases heat fast, faster than most people expect. Cooling jackets flood the reactor walls with chilled water to prevent a runaway reaction. Workers watch sensors like hawks, listening for changes in pitch and vibration. The smell is sharp and chemical, hanging heavy in the air. What happens next determines whether this batch becomes perfect or worthless scrap. After several hours, the mixture thickens into a golden, syrup-like liquid. It flows slowly, moving at less than 1 meter per second through heated pipes. At this stage, impurities are filtered out using high-pressure membrane systems. The sound shifts from roaring machinery to a steady, controlled hum. And just when it looks stable, engineers push it even further. The resin enters a finishing reactor, where molecular weight is adjusted with extreme precision. Temperatures drop to around 80 degrees Celsius, while mixers slow to 30 revolutions per minute. This step can last anywhere from 30 minutes to several hours. One wrong calculation here changes how the resin cures forever. And that's why nobody takes their eyes off the stage. Now the resin faces its toughest test. Robotic arms pull samples every few minutes and deliver them to automated labs. Laser scanners analyze viscosity, clarity, and molecular structure down to microns. Rejection rates stay below 2%. But even that costs millions annually. Still, machines don't make the final call. Here's the moment human skill beats technology. An experienced technician checks how the resin flows between two metal plates. They feel resistance, watch how light bends through it, and decide in seconds. This instinct comes from decades on the floor. And without it, entire production lines could fail. Every year, the world produces over 3 million tons of epoxy resin. The global market value exceeds $10 billion and keeps climbing. China leads production, followed by the United States, Germany, South Korea, and Japan. More than 200,000 people work directly in epoxy-related industries worldwide, and demand is growing faster than anyone predicted. 50 years ago, epoxy was rare and expensive. Today, it's everywhere, from smartphones to spacecraft. In the next decade, production could double as renewable energy and electric vehicles expand. Did you know some epoxy formulas can last over 100 years without degrading? Or that 1 gram can support more than a ton of weight? And we're only scratching the surface. You've followed epoxy resin from deep underground resources to the final quality check. You've heard the machines, felt the heat, and seen the precision it demands. Most people never think about this when they use it, but now you know the truth behind the surface. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.